Y'all look shooketh. Alrighty. We're gonna do some more stuff with I. Our favoriteest ever. We love I. I is the best, right? So what we're going to do is we're going to be doing some quotients. We've done adding, subtracting, multiplying. We're going to do quotients. We're dividing with I. Random object rolling across my room. Love it. So when we are dividing with I, it's in these quotients. This is a word we're familiar with, the conjugate. We used that when we were rationalizing a little bit ago. So I'm going to bring it in here. We got 4 over 2 minus 5i. So the conjugate of the not having a conversation, thank you. Conjugate of our denominator, it's when it has the same pieces. But instead of a minus, we put a plus. Yeah, so because we're forcing a completing the square. But I can't multiply it by just a random number, but I can multiply by the weirdest looking one ever. So if I multiply everybody by this, the conjugate of the denominator, that gives us my numerator. We have 4 times 2, which is 8, plus 4 times 5i, which is 20i. My denominator becomes the 2 times 2, which is 4. 2 times minus 5i is minus 10i. 2 times positive 5i is positive 10i. So those guys cancel out, and we get minus 25i squared. We're forcing it to be completed the square on the bottom. You okay on that piece? But now I see I squared, and we don't like that, so we need to simplify that. So I'm going to leave my numerator the same. We're going to have 8 plus 20i on the top. What's another way that I can write I squared? Negative 1. So this is 25 times negative 1. There we go. That's how we write 1. Or 4 plus 25. So we get 8 plus 20i over, try that again. You were on the right vibe, but there you go. I was going to say you were in the right channel, but made a very simple arithmetic mistake. So be careful with it, okay? That is our answer. There are no more i's in the denominator. You can also write it, if we need to simplify, 8 over 29 plus 20i over 29, and then it looks more like a complex number, like according to the definition. So this is also fine. Those are both fine. I am fine with either one. So we multiply by the conjugate and simplify. So let's do another one. So now we have 2 minus I over 3 plus 4i. So we are going to multiply. Ooh, that's not the right pen. Multiply by the conjugate, which means it's going to have the same terms, the 3 and the 4i, but instead of a plus, it's a minus. Multiplying by that conjugate. So we're going to need to be real careful in our numerator, because this is a multiplying binomials kind of situation, which you can do distribution-wise, or you can box it, or you can do whatever we need to. So 2 times 3 gives us 6, minus 3i, minus 8i, plus 4i squared over 9 minus 16i squared. Because the bottom should always wind up looking like a difference of squares. Every single time. If you pick your conjugate right, the bottom's going to be a difference of squares. Okay? Questions on that part? Because that's the hard part here. Everything else is simplifying. So my numerator, we have 6 minus 11i plus 4. How do I write I squared? -1. And again, in the denominator, we have 9 minus 16 times -1. So we have it in here twice. So when we simplify this, we have 6 minus 4, which is 2 minus 11i over 9 plus 16, which is 25. And that's a fine answer. Yeah, just double check it. Okay. How are we feeling on these? Okay. Not really on the dividing complex numbers. I mean, we'll have more things, but they don't get messier than this on the quotients of complex numbers. It'll have a different title.
That's not actually helpful.
No, it's not. It's okay. But the conjugate thing, it doesn't get more complicated than this conjugate, as far as I'm aware. All right, so we're gonna do the same thing. Our conjugate here is gonna be 6 plus 2i. So we're multiplying by that. 6 plus 2i over 6 plus 2i. I cannot change my equation, so do not just multiply it in one side. I can multiply by funny looking ones, but I cannot just change it. So we're going to have 6 plus 2i minus 7 times 6, 42i. And 14i squared. Should be something like that, hopefully. Yeah. And our denominator, 6 times 6 is 36. Minus 4i squared. We're gonna use this multiplying by the conjugate in quite a few different places when we're rationalizing stuff. So conjugates are gonna come back again and again and again and again. Okay, so we're gonna need conjugates a bunch of times throughout like the year. So that's why we're practicing with the conjugate so many times in so many different ways, is we're going to use it. So when we simplify this, what are we going to get? Hello. Cool. Thanks, Jasmine. We've had a delivery of something. When we simplify this, what do we get? I didn't get 42, so let's work our way through it then. So we're going to have 6 minus 40i minus like that. I'm just writing my next step down here. 36. 4 times -1. Like that. Don't try and jump too many steps at once. I had a lot of people do that on the quiz where we were trying to like do gargantuan leaps. It's okay to write things out. You lose track of stuff when we do 8 steps in one time in our head. I had a lot of people get caught up with silly mistakes because we did too many things in our head at the same time. So when you start having to try and juggle stuff, write it down. It's okay. Okay, because we should have here 20 minus 40i over 40 is what we should have gotten here, right? But now we're going to simplify this, which if you can spot it here, great. If not, split it apart. 20 over 40 minus 40i over 40. Can it easier see the simplification here? 20 over 40 is 1/2. 40 over 40 is 1i, or just I. So I'm 100% okay with us leaving them as fractions, fractiony goodness. I am also okay with you splitting them, but just know we are going to have to be able to simplify them. So if you cannot spot the simplification like this, split them apart to check for it. Yes, dear. You could do 1 minus I over 2. That's totally fine. It'd be 1 minus 2i over 2. Yeah, 1 minus 2i over 2 is totally fine. Common denominator of simplify, divide both by 20. 1 minus 2i over 2. If you don't see that, that's fine. Go with my way.
Is 1 minus 2i over 2?
Mm-hmm. If you don't see where that came from, ignore that sentence and do it this way. Okay?
Why is it not 1/2 minus 2i?
Because 40 over 40 is 1. Okay? If it was 20i, that'd be fine. Or that would have to be 80i to get 2i. All right. Last one like this. And then we're going to move on to, because this is all the stuff we were actually supposed to do after the quiz on Friday, but we didn't. So then we'll get on to the stuff we're really doing today. All right. So then we're going to do the conjugate here. We're going to have our -2 minus I. -2 minus I. And it's okay to do it just like that. You can also rearrange it if you don't like that -2 being in front. I don't care though. So we wind up with, on our numerator, what do we get in our numerator? -14. We missed one. So we've got our -14 minus I. Yep, minus 4i. Don't skip that one. Minus 2i squared. It is 100% okay to draw the arrows. Keep track of stuff. You do not have to do stuff in your head. What's in our denominator? -2 times -2 is +4 and minus I squared. So when we start to simplify, we have our -14 minus 11i minus 2 times I squared becomes +2. Because I squared is -1 minus -2 times -1 gives us +2. And then we have 4 plus 1 in our denominator. So I wrote them slightly differently than I did on the previous steps, but it's the same thing. So we wind up with negative 12 minus 11i over 5. Okay. How are we feeling on these conjugates? Pretty good. So then we're going to work on simplifying down into these complex numbers where we will then use the conjugate. Because we're going to look at square roots of negative numbers. So this is just adding like one step onto it, onto our simplification stuff. It looks really scary. Square root of negative 36 over the square root of 9 times the square root of negative 100. What's another way to write the square root of negative 36? 6i. What is a way to write the square root of negative 9? 3i. Times the square root of negative 100? 10i. So the first part looked real scary. This part's significantly less scary. Okay, when we see square roots of negative numbers, switch it into i's. So we wind up with 6i over, what is 3i times 10i? 30i squared. Uh-oh, I squared. Negative 1, so we wind up with an answer of 6i over negative 30. And simplify this. What are they both divisible by? 6. What? 6 times what gives us negative 30? Negative 5. I over negative 5. Okay. They look a little scary with all these square roots, but I promise they're fine. What's up?
We like figuring out like a GCF like that.
Mhm.
Do we have to like put in parentheses and put it on the outside?
If it's a GCF and we're factoring it out, yes. If we are simplifying and dividing top and bottom because it's essentially 1, no. All right, next one. Same process. Square root of negative 36 times the square root of negative 49 all over the square root of negative 16. So how do we write the square root of negative 36? 6i. How do we write the square root of negative 49? 7i. And our denominator is 4i. So we have 6i times 7i plus indeed. What? 42i squared over 4i. So what's our numerator? Negative 42 over 4i. Remember, I squared equals negative 1. Negative 1 times positive 42 is negative 42. However, now we have an I in the denominator, and that's not good. Not by 4. Not by negative 4. What is it that I need to get the I out of the denominator? Another I. So I need to times this denominator. I need another I there. But I cannot just multiply by I have to multiply by a weird looking one. I over I. I over I is 1. It'll simplify. We only need the conjugate if it's adding or subtracting. If there's a plus in there, that's when we use a conjugate. This is just trying to make it be no radicals in the denominator. So we have negative 42i over 4i squared. I squared is negative 1, right? So we have negative 42i over negative 4. Can I simplify that further? How? Yeah, I could divide both sides by both pieces by negative 2. And we're going to have an answer of 21i over 2. Whenever you have negatives top and bottom, the negative signs cancel out, and we do need to simplify top and bottom. Hello, darling. Okay? So square roots of negative numbers, we treat them just like i's. Now we're going to smash this together with the things we just did. So they look scarier. 7 plus the square root of negative 64, negative 2 minus the square root of negative 81. When we see square roots, especially with negatives, when we see any square root, let's try and get rid of that radical. So my numerator is going to be 7 plus, how do we rewrite the square root of negative 64? 8i. And negative 2 minus, what's in our denominator? 9i. And we are into exactly what we started today with. To get rid of the I in the denominator, we're going to multiply by its conjugate. And give us full space there. There we go. Times the negative 2, my 9i, and this time it's going to have a plus. Negative 2 plus 9i. When we are done with imaginary numbers or complex numbers, there should be no i's in the denominator. No i's in the denominator by the time we're done. Don't make me laugh when I'm drinking coffee, man. Come on. All right. So let's multiply it out. 7 times negative 2 gives us negative 14. 7 times 9i gives us what? Eight I times negative 2 gives us minus 16i. And 8i times 9i, 72i squared. And our denominator becomes negative 2 times negative 2, which is 4 minus 81i squared. And then we're simplifying. So we have minus 14 plus 47i. I squared is negative 1. So we have minus 72 over 4, and then again, I squared is negative 1, so plus 81. And we have to simplify one last time, and we're very nearly done with this one.
Negative 86 plus 47i.
Mm-hmm. Mm-hmm. And then it's a good idea to check to see if we can simplify this at all. We can't, but it's a good idea to check. Okay. One more like this before we kick it up a notch. But not in the imaginary number way, like regular kind of way. So we have 4 plus square root of negative 81 to minus square root of negative 9. So this becomes 4 plus what? 9i. And 2 minus 3i. First step is to get your imaginary numbers instead of radicals, and then we get our conjugate. So the conjugate here is going to be what? 2 plus 3i. Good. And we do 2 plus 3i over 2 plus 3i. When we multiply that out, 4 times 2 gives us 8. 4 times 3i gives us 12i. 9i times 2 gives us 18i. And 9i times 3i gives us 27i squared. I'm on the edge of my screen. And it's crooked, but that's okay. And our denominator is going to be what? Perfection. 4 minus 9i squared. So let's simplify this. 8 plus 30i minus 27. Yeah, I hear lots of whats. I squared is what? Negative 1. 27 times negative 1. Minus 27. 12 plus 18 is 30. You okay on all the pieces now? All right, so then we have 4 plus 9 in the denominator. Same process. I squared is negative 1. 9 times negative 1. And we get our answer of 8 plus negative 27, giving us negative 19 plus 30i over 13. Okay, so they're a little weird. They're a little long. They're going to get longer. They're not too awful, I hope. Nope, that's not it.
That's not it for today?
No, it's not it for today.
You said that was the last
Last one like that. I did say like that. Okay, because now we got to figure out how we get into those. Where does that come from? It's not just spontaneously generated chaos. So we're going to look at solving. We've done solving a bunch. Whenever we see a quadratic and we're asked to solve, our first instinct is going to be to check and see if it's factorable. So we can check. Multiplies to be 13, has to be negative 6. Is there anything that'll work? So it's not factorable. What is that F? There we go. What is that? If it's not factorable, how can I solve it? Quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And we're going to fill in our values. X equals the opposite of b, negative 6, plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is 13, divided by 2 times a, which is 1. Okay? Fill in all the pieces, then simplify it. So you get x equals, the opposite of negative 6 is positive 6, plus or minus the square root. Yeah, because negative 6 squared is positive 36. 4 times 1 times 13 is negative 52. 36 minus 52 is negative 16 over 2. How can I rewrite this? 6 plus or minus 4i over 2. Can I simplify that? To what? 3 plus or minus 2i. Yay, we solved it, we solved it. That's the answer. You can split it if it works better for you to see it as two answers because it's a quadratic. X equals 3 plus 2i and x equals 3 minus 2i. That is equally as valid. So this is fine and this is fine. Okay? There's 2 more. This one and then there's one more after this. That's like the worst, like the next one is like the worst one on the homework. So here we have a sum of cubes. This is when we think about our special pattern for the cubes thingy and soap. So we gotta clean it up. Yup. Same, opposite, always positive for the signs. So we think about our cube root of each piece. Cube root of x cubed is what? X. Cube root of 125, 5. So when we're putting this in factored form, we take the x and the 5, and this is when it has that same sign, soap, same sign. Then we take x squared, opposite sign, so it's going to have minus 5x plus 25. Always positive is the last one. So you never know when these things we've done before are going to come back into play. And I have to move my parentheses so I can actually fit the equal 0. Do not randomly add or drop zeros. I had that happen a few times on the quiz too, where we would start with a solving and then randomly we would turn it into an expression. And we would drop the 0. If there's an equal sign, keep the equal sign. If there is not an equal sign, do not spontaneously generate an equal sign. You are just simplifying if there's not an equal sign. All right, so let's find some solutions here. What's the solution on this one? What's my 0? X equals negative 5. Sweet, we love that one. Doesn't hurt. Easy to do. Yippee dippy. Because x plus 5 equals 0. Cool, cool, cool. So let's look at this guy. Can we factor that? So what do we do? Quadratic formula. So x equals the opposite of b, which is going to give us a positive 5, plus or minus the square root b squared, 25, minus 4 times a times c. 4 times 1 times 25 is 100. I made a jump there. Are we okay? Okay. Let's say this is a jump that I would believe we can do in mental math. 100% I buy we can do this one. Jumping down here, I'm not entirely sure I would buy that we can do this mental math. If we just jump to here, I don't always buy that, okay? Boom. Exactly right. Exactly right. So simplifying this, we got to find the perfect square inside of it. So our solution is going to be 5 plus or minus. How do we write the square root of negative 75 with no negatives under the radical? 5i square root of 3. I am 100% okay with that order. I am also okay if we put 5 square root of 3i. Just make sure your I is out of the root. I do not care what order you put it in. I feel like this makes way more sense for my brain because then the I is not under the radical very, very clearly. But if you like all your numbers together and your I at the end, I'm okay with that too. Over 2. And that's our solution. It's not pretty, but it's there.
Wait, why is square root of 3? Isn't it square root of 2?
25 times 3 gives you 75. No, it's okay. Always feel free to ask and double check. Because this happened before. But we split this to be 25 or negative 25 times 3. So square root of negative 25 gave us 5i. Okay? What's up? Yes. The other solution we have is negative 5. Because if you remember back to when we were talking about number of solutions back in like algebra 2, when you have a cubic, we should have 3 solutions. 1, 2, 3. Okay, we got one more. Don't pack your book up. There's one that looks like this on the homework. We got 3 minutes. I got 4 minutes. There's one like this on the homework. And we get panicked. You have homework every day, sweetie. Homework. It looks really scary because it's x to the 4th. What if we just like switch our variable? Remember u substitution? Yeah, I know. I'm going to switch my variable. I'm going to say, what if... You can't square root the whole thing, but I get the vibe. Okay? I'm going to rewrite this with a new variable. I'm going to say, I don't like having the x to the 4th there. But I could rewrite this as 4 times u squared. 25. I'm changing my variable because I don't like it. Because I'm saying I would like this term to be just 1u.
Oh, I get it.
You can do that. It is called a u substitution. And then the book went to be a jerk on one of the questions. They actually use u as your variable because they're jerks. Yes, dear. Because there's sums in there, you'd have to factor it, which I think we can do. We can't square root the sums of things since it's adding. If it was all multiplied, absolutely, I'd be right with you and it'd be so much easier. Okay? So once we do this, we can actually factor this. Because it is all squares.
So would this still be like x equals would be like u equals like when we do quadratic formula for this?
Uh-huh. And then we got to switch it back into x's because we need our x solutions. Okay? So you can quadratic formula it. You can also factor this. 144 and 25. And it's going to be, I'm going to give us do a 16 and 9. I'm going to give it to us because I don't want us to like take our time doing that. So when it's factored, however you choose to factor, we should get 4u plus 9 and u plus 4. Right? That's our factored form. When you have an a value, stop just taking these values. If you have an a value, you have to factor it with something. Box, grouping, I don't care, bottoms up, there's lots of different methods. Factor it somehow. So we're going to get our u solutions as -4 and -9/4, right? But I don't want u. I want x. X squared equals -4. X squared equals -9/4, right? Because I had switched out u to be x squared. I got to make sure I get back to x's by the end. Square root both sides.
Yeah, I don't get it.
We'll talk more about it, but there's one just like that on the homework. And square root both sides. Yep, and then so we'll get plus or minus 2i plus or minus 3i over 2. Okay? But I wanted us to see one like that that had that switch the variable to be something less gross. Have a great rest of your day. Happy Monday.